So today we're going to start our unit on reactions in aqueous solutions, which is chapter 8, and we're going to talk about the first section, which involves precipitation reactions. So remember, a precipitate is a solid that is formed usually when you combine two aqueous solutions. Remember, aqueous means something that will usually dissolve or dissociate in water. Okay, so first we need to talk about some signs for how we know when a reaction will occur. And there's basically 4 factors that cause reactions to occur. First one is formation of a solid. That would be the precipitate. Second one is formation of water. Okay, so we're forming some products. We know that we have a reaction when we form certain things. The third one, which we're going to talk about later in this unit, which involves what are called oxidation reduction reactions, is transfer of electrons. And the fourth one is formation of a gas. So we're either transferring electrons or forming something, okay, a solid, water, or gas. Okay, so today we're going to talk about reactions in which a solid forms. Those are precipitation reactions. So precipitation is the formation of a solid. Now, you usually think about precipitation like with weather, like snow or rain or whatever, but in chemistry, it's just formation of a solid. So the precipitate is the solid that forms. So you take 2 liquids, you put them together, and you form a solid. And we will do this as a lab later on in this unit. So a precipitation reaction, then, is the name of that type of reaction where we take 2 aqueous solutions and we form a solid. These are also known as double replacement reactions, and when we talk about how the chemicals go together, we'll talk about why that works. Okay, and so usually precipitation reactions will follow this form. Yeah. Okay, and so we have the cation and the anion of one compound plus the cation and the anion of another compound, and as you can see, basically anions are switching places and then the cations are switching places. And so we get A to D, so a cation with a different anion, and C to B, so our second cation with the other anion, and we'll look at this in more detail. Okay, so let's look at an example. So when an aqueous solution of potassium chromate is added to an aqueous solution of barium nitrate, what products are formed and which one is a solid? So remember all the stuff that we talked about with naming compounds, making sure that your compound was neutral, that the charge is balanced out. All of this stuff is going to, again, become important. And so that's why all this stuff keeps cycling. You're never kind of losing it. It's always coming back up. Okay, so potassium chromate is K2CrO4, and barium nitrate is Ba, and then because barium is a +2 charge, we need 2 nitrates in order to make that neutral compound. So this is following the form AB plus CD. Potassium is our first cation, chromate is our first anion, barium is our second cation, and that nitrate is, this should be C, not A. Nitrate is our second anion, which is D. So they're basically going to switch places, which is why it's called the double replacement reaction. And A is going to go with D, and C is going to go with B. Because remember, we always want to list the cation first. Okay, and that's why A and C are our cations. So we need to figure out what products are possible in this reaction and what chemical species are going to be present in solution. So of our products, are any of them going to be solids, and then are any of them going to be aqueous? So solids are what we would call insoluble. Okay, well, normally ionic compounds are the type of compounds that will form double replacement reactions or precipitation reactions. So almost always when a solid containing ions, remember ions are charged particles, dissolves in water, the ions will separate or dissociate. So if you remember from the pickle lab that we did, we took hydrochloric acid, vinegar, salt. Those were our ionic compounds because they dissociated or broke apart into their ions in water. We also tested sugar. Sugar did not conduct electricity because it was not ionic. It dissolved, but it did not dissociate. And so that's the difference. Okay, so we have different types of electrolytes. A strong electrolyte is a substance that when dissolved in water produces separated ions. It will dissociate completely. Salt, NaCl, would be a strong electrolyte. It dissolves or dissociates completely. Other types are weak electrolytes, which kind of dissociate, but not all of them. And then non-electrolytes don't dissociate at all, and a non-electrolyte could be something like sugar. So if we go back to our example, our potassium chromate and our barium nitrate, if we take this and break it apart into all the ions, because remember, both of these solutions or both of these compounds are aqueous, and that means they're going to dissociate in water. So because we have this 2 here, that means we have 2 potassium ions plus a chromate ion plus a barium ion, and because of this 2, that means we have 2 nitrate ions. So we're listing all of the possible ions in this solution right now. And then we want to try to put them together and see what products we're going to form. Okay, remember, every compound must have a net charge of 0. We want to make all our compounds neutral. Okay, and the products must contain both anions and cations. Remember, an ionic compound contains a positively charged cation and a negatively charged anion. Most ionic compounds contain only one type of cation and one type of anion, so these would be binary ionic compounds. That's what we've kind of studied so far, and that includes polyatomics, so that's kind of what we're going to focus on. Okay, so let's go back to our example. We know our cations are potassium and our barium. We know our anions, or negatively charged particles, are chromate and nitrate. Okay, so our potential products are basically going to take all these cations and all these anions and just put them together and form compounds. So our potential products are potassium chromate, putting A and B together, potassium nitrate, putting A and D together. Now if we take barium and put it with both anions, we have barium chromate and barium nitrate. So these are our potential products. Does it mean that they all are products? No. Okay, well, potassium chromate and barium nitrate are the reactants. So we know that they can't be products because that wouldn't make sense to have reactants as products. We're not changing anything. And so what that means is if we cancel both of those out, then the only 2 we're left with are potassium nitrate and barium chromate. So basically our anions switched places, and that's why it's called double replacement, because both things switched and got replaced. So now that we have our products, that's the first step. Okay, and we've checked charges also, which is very important. Charges carry, quantities don't. So if you notice in the reactants, we have 2 potassiums, but in the product, we only have 1 because potassium is a +1 and nitrate is a -1. Whereas here, barium is a +2 and chromate is a -2. And so 1 and 1 make the compound neutral. So the charges carry, but the quantities don't. And that's where all those naming compounds and writing the compounds, where all that comes into play. Okay, so now that we have our 2 products, we need to decide which one is the precipitate or which one is a solid. And we need to use solubility rules for that. Okay, so these are things that would be given to you on a test or quiz. You don't need to memorize them, but basically, with how often you're going to use them, you'll probably memorize them anyway. Okay, so let's talk about some vocab. So a soluble solid, something that's soluble, dissolves readily in, for example, water, because that's going to be our main solvent. So salt would be an example of a soluble solid. An insoluble solid is something that does not dissolve in water, or it could be what's called slightly soluble. Okay, slightly soluble means only a little bit of it will dissolve in water, but it's not enough to make a difference, and so we would consider it to be insoluble. Now the problem is, when something is insoluble, we would say it's a solid. And so after the compound, we would put our physical state, which is an S in parentheses. So it's really easy to get that confused because we think soluble S, but really it's insoluble because it's a solid, and that's why we put the S for the physical state. So keep that in mind when you're writing physical states. Okay, insoluble salts are what we call precipitates. Okay, and salts and ionic compounds are often used interchangeably. There are lots more salts out there than just sodium chloride, and if it's an ionic compound, usually we just say it's a salt. It's kind of like a slang term for ionic compounds. You can find a solubility chart on page 218 in your textbook, or I also have a laminated chart, but I mean, if you just Googled solubility rules, you would find all kinds of charts. So whichever one works for you, they're kind of all the same. Okay, here's an example of one. Okay, so these are general solubility rules. Okay, and you can also find this in your textbook. There are certain things that are always soluble. Anything with nitrate. This is a huge one. If you can remember this one, you're going to know like 75% of all your compounds. Okay, so you can pause it if you need to and take a look at this. You can also refer to the one in your textbook or the one that we have in class, but you're going to use this to figure out whether or not your products are soluble or insoluble. And like I said, the more you use it, the more you'll memorize it. Okay, so steps to predict precipitates. So to predict precipitates of when 2 ionic compounds are mixed, it's good to follow these steps. First, write the reactants as they actually exist before any reaction occurs. So as you saw in the example with the potassium chromate and the barium nitrate, we just wrote the reactants, making sure the compounds were neutral, and include physical states. Almost always, all your reactants will be aqueous. Then, predict your products. Switch both your anions. Do your double replacement reaction. Make sure your compounds are neutral. And that's your second step. Then, use your solubility rules to determine which, if any, of the predicted products forms a solid. So use your solubility rules, check your products. Sometimes you'll have a reaction where you don't form any solid. We'll talk about that in a second. The reaction will go to completion only if there is one insoluble compound. There has to be one solid formed. If there's two solids formed, very unlikely, or no solids formed, which is more likely, then you would write no reaction. Okay, so the reaction should follow the form AB plus CD, and then if you'll notice, we are, whoops, oh, that's not what I want. There we go. We are switching the anions. Okay, so now A is going to D, and C is going with B. So that's the form it should follow. If, like we talked about, they were all aqueous, then we would write NR, which stands for no reaction. Technically, we're not going to see anything happening. We're still going to have all these ions floating around because everything is aqueous. So we're not going to form anything. Okay, so let's look at a few examples. So when an aqueous solution of silver 1 nitrate is added to an aqueous solution of potassium chloride, a white solid forms. Identify the white solid and write a balanced reaction. Okay, so we have silver, which is Ag. I know that this 1 means it's a plus 1. And nitrate is NO3, 1 minus. Well, 1 plus, 1 minus, it's good. It's a neutral compound, and we know that it's aqueous. So now we have our other reactant of an aqueous solution of potassium chloride. Potassium is a 1 plus, chlorine is a 1 minus, and it's aqueous. Now, if you don't need to write the charges to make it neutral, you don't have to write them. But I like to write them because that helps remind me that the charges carry when I go to the products, but the quantities don't, and that makes things a little easier. But again, if you write a neutral compound, you don't have to put the charges. It's completely up to you. Now, because everything is 1 plus and 1 minus, and everything is 1 to 1, that makes things a little easier. I'm going to start with my silver again. But this time, instead of being combined with the nitrate, I'm going to combine it with the chlorine because that's my other anion. Okay, well, it's 1 plus, 1 minus, so I'm good there. I don't know physical state yet. I need to look that up in my solubility rules. My other product is the potassium, and the only other anion left is the nitrate. Okay, 1 plus, 1 minus, it's good. Now, I remember from solubility rules that nitrate, NO3, anything mixed with nitrate is aqueous. So I'm going to make that AQ. Now I need to check on my silver chloride. Well, let's go back to our solubility rules. Okay, so if I take a look at my solubility rules, let's see. Here's chlorine. So all chlorides, bromides, and iodides are soluble except when mixed with silver, mercury, and lead. Okay, so that means that anything with silver and chlorine is going to be insoluble. Okay, so let's go back to our example. Okay, so we have silver and chlorine. So most things when combined with the chloride ion are aqueous. However, we have 3 exceptions: silver, mercury, and lead. And since silver is one of those exceptions, that means that this is our solid or our insoluble compound. Okay, and we know that we also have a balanced equation because all our compounds are neutral and everything is 1 to 1. Okay, let's try another example. Okay, predict what will happen when aqueous potassium nitrate. All right, so we have potassium, nitrate, it's aqueous, and aqueous barium chloride. Okay, barium is a 2 plus, chlorine's a 1 minus, so that means I need 2 chlorines to make it neutral, are mixed. Write a balanced reaction. Okay, so let's predict products. So let's start with potassium. It can't go with nitrate anymore because that's where it was as a reactant, so the only other anion available is chlorine. Now remember, charges carry but quantities don't. So I'm going to carry the 1 minus charge for chlorine, but I'm not going to carry the 2 here because that was put there to make sure barium chloride was a neutral compound. I don't know if it's aqueous or not, so let's go on to our next compound. our next cation, or only cation left, is barium. The only anion left is our nitrate. Now, because nitrate is a 1-, I know that I need 2 of them. I know that anything mixed with nitrate is aqueous. And I remember from the previous example that anything with chloride ion was aqueous unless it was silver, mercury, or lead. And since potassium is none of those, I would write AQ. And so basically this means no reaction. We have everything is aqueous. So basically what's really going to happen is that because these things are aqueous, they're all going to be as their ions. We're going to have some potassium floating around, some nitrate floating around, some barium, some chlorine. They're not going to form products at all. And so we would say no reaction. Okay, so here are 2 more examples. What I would like you to do is try these on your own exactly the same way that we did them together. Okay, make sure your compounds are neutral. If you're not sure, try your best and we'll go over them. Okay, again, predict your products and then find your solubility. And you can go back to the one we have in here. You can use one in your textbook. Okay, so try these 2 examples. You can pause it here to try example 3 if you'd like. Okay, and then here's example 4. Okay, so try these 2 and then we will go over them and make sure that you don't have any questions. Have a good day.